Okay, in this video we are going to talk about chemical bonds. Now in chemical bonds there are mainly three types of bonds: ionic bonds, covalent bonds and metallic bonds. Now first let's talk about ionic bonds and see what ionic bonds are. Now initially, if you are talking about ionic bonds, first thing you should know is ionic bonds are always taking place between a metal and a non-metal. For example, now in the periodic table you see this S block elements, these D block elements, and here we have the metalloids. Everything on the left side are metals and everything above the metalloids right here are non-metals. So an ionic bond will always take place between a metal and a non-metal. Now talking about ionic bonds, one of the main things that you should know about ionic bond is this. Now we all know metals like to actually remove electrons, because for example, if we go back to the periodic table, metals, especially these S block elements, they can gain an octet by removing either 1 or 2 electrons. So they prefer that. So because of this reason, they would be giving off their electrons and forming positive ion. Now here you see sodium, it gives its single valence electron away, it donates it and becomes sodium plus ion. And what happens in this process is this single electron which is given off by the metal is accepted by a non-metal. Now in this example it's chlorine, where the chlorine takes the free electron and forms an anion. It's negatively charged, and now chlorine has a complete octet. Now both sodium and chlorine, they are stable, they have the complete octet and they are chemically stable. And this chemical stability is the thing that drives for them to make this ionic bond. Now what is ionic bond? Now actually the ionic bond is this attraction between sodium plus ion and chlorine minus ion. You see this cation and this anion, they are attracted to each other because positive attract negative. So this attraction is the thing that allows them to have this ionic bond. Now other examples than sodium chloride that we have is magnesium oxide, magnesium chloride. Any metal and non-metal can easily form this ionic bond. Now here you see this very complicated structure. Usually ionic compounds, they form these complicated structures and these are called lattices. Usually a positive ion is surrounded by negative ions and a negative ion is surrounded by positive ions, and this continue to form. And this uniform structure is the reason that ionic compounds have a really high melting point. Why? They have so many electrostatic bonds around that they can withstand outside changes. But at the same time, this structure gives its brittle nature. For example, now here I told you guys one positive ion is surrounded by negative ion and negative ion is surrounded by positive ions. Now they are in an orderly fashion. So for one reason, if you just disturb this lattice structure, what would happen is positives and positives started repelling, negatives and negatives started repelling, breaking the structure apart. That's why things like sodium chloride and things like calcium oxide, like things like limestone, they are very brittle. Here, this is another example for ionic compound. Always remember, key thing to remember about ionic bonds is that they are forming between a metal and a non-metal. Some properties of these compounds: high melting point, very hard substances, but even though they are hard, just like I said, they are very brittle. Okay. Now let's move to the second type of bond, which is covalent bonds. Now, in covalent bonds, they are a pretty special type of bonds because covalent bonds usually takes place between nonmetals. Now, unlike ionic bonds, these do not, completely remove electrons or completely gains electrons. Instead, what they would do is, you see here this picture, they would share electrons between two atoms. Now here in this case, chlorine, in its outer shell, it has 7 electrons. It just needs one more electron to be complete. So it's going to share its one electron with another chlorine which is willing to share its electron. So in a net effect, both chlorines obtains approximately 8 outer electrons by sharing each of their individual valency electron. This is the concept of covalent bonding. Now, the important thing to remember in covalent bonding is that they are always sharing the electron, and depending on the electronegativity of these atoms, you can actually either have a polar bond or a non-polar bond. Now let's talk a little bit about what is polar and what is non-polar. Now let's get back to our periodic table. Now here in our periodic table, this actually gives you the Pauling's electronegativity values. Now the concept of electronegativity means the ability of the atom to pull an electron towards itself from a bond. So for example, in this bond, you have bond between chlorine and another chlorine atom. So electronegativities of both of these are same. Why? They are the same atom. So what ended up happening is their electronegativities, that means the ability of this chlorine to pull these pair of electrons they are sharing towards itself, and the ability of this to pull the electron pair they are sharing to itself is the same. So they are not going to move. So something like this, where the electron pair is shared equally, is called a nonpolar bond. But think this now, hydrogen chloride. Now if you look at the periodic table again, hydrogen electronegativity 2.1, chlorine electronegativity 3.0. So that means chlorine has a higher ability to pull the electrons in a bond towards itself. So what's going to happen is, on this bond, chlorine can actually pull this electron pair shared between hydrogen and chlorine towards chlorine more than hydrogen. So what this is going to do is, for example, now if I draw here, so you have hydrogen, you have chlorine. Now initially, if they are sharing this electron pair equally, the electron pair should be in the middle. So both of them can actually feel the two electrons. But now, since chlorine has higher electronegativity, this electron pair is going to come more closer towards chlorine. This is going to give chlorine a delta negative charge. Now here, delta negative or delta positive, it means basically a very small charge. So here chlorine has a small delta negative charge because the electrons are more closer to chlorine, and hydrogen has a small delta positive charge because the electrons are not near hydrogen. Now you see there are two poles in this molecule. Because of this polarization, we call this is a polar covalent bond. Okay, remember this only arises due to the electronegativity difference. Earlier in chlorine, we didn't see this. Why? Chlorine had the same electronegativities in both of the atoms. Now, another important thing arises from polarity is how polar substances dissolve in polar substances and non-polar substances dissolve in non-polar substances. We will learn about this in the next chapter when we are talking about solutions, but for now remember the importance between categorizing compounds at polar and non-polar. Now here we see couple of more covalent compound. We have methane here, which is sharing 4 electrons with 4 hydrogen atoms. We have ammonia, which is sharing 3 electrons with 3 hydrogen. We have water here, which is sharing 2 electrons with 2 hydrogen. Now, when talking about the properties of covalent compounds, one thing that we can say for certain is most covalent substances, they have a low melting point, because if you can see here, the covalent bond is within few atoms. Now earlier in ionic bond, the ionic bond was between large number of ions within the compound, but here the covalent bond is just between few atoms. So because of this, the compounds which are covalent have a low melting point, and also they are generally, so for example here methane, ammonia, water. Methane is a gas, ammonia is a gas, water is a liquid. So most covalent compounds are like that. They have more soft physical properties. Now that sums up the major features and properties of covalent bonds. Now let's talk about metallic bonds. Now metallic bonds, they are pretty important because all the metals that exist in nature have metallic bonds, and the importance of the metallic bonds arise due to the property of metals. Now we all know metals, for example, if I go back to periodic table, S block, D block, part of the P block, these are metals. Now one of the key properties of metals are they like to remove their electrons, specifically their valence electrons. So what ended up happening is these valence electrons create this sea of electrons. So these positive ions are immersed in this sea of electron, and this sea of electron and the positive ions have strong metallic bonds. These are the bonds that keep the metal in a rigid shape. Due to these metallic bonds, the metals are really strong. They have high melting point, high boiling point. They have good electrical conductance. Why? There are free electrons. They can conduct electricity freely. And they have good heat conductance. Same reason, they once again have large number of free electrons. So due to these free electrons, metals obtain this large number of very useful properties. Now this model is called electron sea model. Remember the name because it's the name of this model. So using that model, we can explain properties such as malleability, electrical conductance, heat conductance of metals. Now we have talked about the main 3 chemical bonds in compounds: ionic, covalent, and metallic. I want you guys to further investigate into different compounds and trying to see what are the major chemical bonds that they have. I hope you guys learned something, and if you have any questions, leave a comment. Take care. Bye.